Hello and welcome to another session on difficult questions. This is November 23 to 32. Okay. First it says sketch on an Argand diagram, shape the region whose points represent the complex number Z. What I'm going to do is I'm going to add a grid because the last time I tried to draw it without a grid, it got very complicated. So that's my grid that I have in front of you. First, I need to draw a circle with 4 plus 3i as the center. So I'm just going to draw it here. 4 and 3i. Okay, and 2 is my radius. Okay, and then I want to shade inside the circle, and REZ is less than or equals to 3. So real value of Z, so the real coordinate is here. The real value of Z is less than or equals to 3. So I'm going to draw a vertical line at 3 and say that it has to be less than. So I'm going to shade this part only. Okay. Then that's the first part. The second part says that I want to find the greatest value of arguments of Z for points in this region. Okay, greatest value of argument of Z. So the greatest value of argument of Z is going to be a line that stretches from here and becomes a tangent here. Okay, again, the tangent is important. I'm going to label this 4 comma 3. Uh, and I'm going to find this entire angle that I want to find. Okay, this is the entire angle that I want to find. But obviously, I'll have to split it up because there's no one way of directly finding this. What I'm going to do is I'm going to first draw a straight line from here and say that I can simply find the argument of 4 plus 3i, and that's going to be tan inverse of 3 over 4. What is that in radians? Let's quickly calculate tan inverse of 3 divided by 4. That's 0.644. Okay, and so I have that part. That's called, let's call that theta. Okay, for the other green part that I have, I'm going to draw it from the center here and say that this is 90 degrees. It has to be a right triangle because radius and tangent meet at 90 degrees, and I'm going to find that angle. I know that this distance is 2 because it's the radius. Can I find the distance, this one? Yes, I can just simply say that this is 3 square plus 4 square, which is 5. So let's call that alpha. Alpha equals to sine inverse of 2 over 5. That's sine inverse of 2 over 5, 0.412. Okay, total argument, I have 1.056, which is going to be 1.06 correct to 3 significant figures. Let's just check if we are doing this correctly. November 23, 32. Question number 4. 1.06 radians, yes. Okay, and we shaded correctly and everything. So that is the entire question then. Okay, moving back to the questions then. Let me just mark this as a bookmark. Okay, moving on. I have this question. It says find the exact value of x into x plus 1 divided by x squared plus 4. So the first thing that I noticed about this question is that this looks like an improper fraction to me. Okay, whenever you have improper fractions, remember that in partial fractions you used to break them up into their partial fractions. Now there's just one factor in the denominator, so it's going to break up like this. You could also do long division and get done with this, but I'm just trying to show you that this is actually a partial fractions question. Okay, how do you obtain A? You take the highest powers in the numerator and highest powers in the denominator with their coefficients, and you say that this comes out to be 1. Okay, so x squared plus x over x squared plus 4 equals to 1 plus bx plus c over x squared plus 4. Okay, let's do partial fractions. It's going to be 1 into x squared plus 4 plus bx plus c into x squared plus x. Okay, I've gotten rid of the denominators. Now let's take x as 0 first. So 0 plus 0 equals to 1 into 4 plus 0 plus c. So c comes out as minus 4. Then taking another value for x, let's take x equals to 1. So 1 plus 1 equals to 1 into 5 plus b plus c. So I get 2 minus 5b plus c. C is minus 4. So b comes out as 1. So my partial fractions that I have now are 1 plus x minus 4 over x squared plus 4. Now this is what we call a proper fraction. I can't split this further to integrate this. 1 can be simply integrated to x. Let's start thinking about how to integrate this part. Now the idea for this part is, and it's come up several times in the past, in the recent past papers, is that you can split the numerator. Okay, what that gives you is it gives you integration by recognition here. Okay, and here it gives you a tan inverse integration. So this becomes the integration of 1 is x half ln x squared plus 4. The differential of the denominator is now available in the numerator, minus 4 tan inverse. Okay, let's recall our tan inverse. It's x squared plus 4. So there's going to be half outside tan inverse of x over 2, and then with limits. Okay, I'm going to switch back to a black pen and 0 to 6. So I have, let's plug in the limits here so that we can see them clearly. X plus half ln 40 minus 2 tan inverse 3. Does it say exact value? Exact value, yeah. I must have done something wrong here. Tan inverse of 3 can't be an exact value. Let me check. It's not. Let me check my working first. This is also November 2332. No, it's tan inverse of 3 even in the answer options. So answer script. Otherwise, I thought it might be something in pi, but it's not the case. 0 plus half ln 4 minus 2 tan inverse of 0. Okay. 6 plus half ln 40 minus 2 tan inverse of 3 minus half ln 4 minus 0. So 6, I can take a half common and say that this becomes ln 40. And since minus ln 4, so ln 4, 40 divided by 4, 10. Okay, that's my final answer. Okay, that's also November 2332. It is given that 2 plus 3ai a plus 2i equals to lambda times 2 minus I, where a and lambda are real constants. So that 3a square plus 4a minus 2. Okay, 4a minus 4. Okay, so I need to get rid of the i's. So basically what I'm going to do is I'm going to multiply this a plus 2i on the other side and then do a comparison of real terms with real terms and imaginary terms with imaginary terms. So I get 2a lambda minus a lambda I plus 4 lambda I minus 2 lambda I squared. Okay, so 2 a lambda, and that in last term will give me plus 2 lambda minus plus 4 lambda I minus a lambda I, just arranging them so that the comparison is easier. So what's the real part on the left hand side? It's 3. What's the real part on the right hand side? It's 2a lambda plus 2 lambda. And the imaginary part is 3a again, 4 lambda minus a lambda. Okay, my task is to get rid of the lambdas. So what I'm going to do is I'm going to take a substitution for lambda wherever it's convenient from. I think it's convenient from here. My bad. Lambda 4 minus a. So 3, 6a square, 4 minus a plus 6a, and that also has a denominator 4a minus a. So 12 minus 3a equals to 6a square plus 6a. So 6a square plus 9a minus 12 equals to 0. There is some mistake. Let's check what our mistake is. I'm not getting 4a, I'm getting 3a. This was never 3, this was always 2. I make these silly mistakes in a lot of places. Okay, dividing everything by 2 gives me the required expression. Moving on to the next part, it says hence find the possible values of alpha and the corresponding values of a and lambda. Okay, so I'm going to solve this quadratic. Okay, I'll put my quadratic on my calculator. A is 2 over 3 and a is minus 2. Lambda was 3a over 4 minus a. So I get 3 times 2 over 3, 4 minus 2 over 3, and 3 times minus 2 over 4 minus minus 2. Lambda is 3 over 5. And lambda is minus 1. Okay, I hope those are the correct answers. Yes, those are the correct answers. Let's move on to question number 9. I think that's also marked as a difficult question. The diagram shows a curve y equals to sine x cos 2x For the maximum point M where x equals to a, the shaded region between the curve and the x-axis is denoted by R. Okay, the diagram shows the curve y equals to sin x cos 2x for x this and maximum point M where x is this, the shaded region between the curve is denoted by R. Find the value of alpha correct to two decimal places. Okay, so dy by dx, the differential of sin x is cos x, and the differential of cos 2x is minus 2 sine 2x. So u dash v plus v dash u should equal 0. Cos x, cos 2x. Now I have multiple options. I could change this entire identity to cos and sort of or sine, whichever one fits better. Or I could do this and change this to tan instead. Okay, so sine x, sine 2x, 1 over 2. So tan x, tan 2x, tan x, and 2 tan x over 1 minus tan square x, 2 tan square x. I get 4 tan square x equals to 1 minus tan square x. 5 tan square x equals to 1, and tan square x equals to 1 over 5. Okay, then I mark my quadrant, take a root and say that this is plus minus, but obviously I just need the first answer, so I'm just going to say that I'm going to take the first one and get done with it. Okay, so what's alpha? Alpha is tan inverse of 1 divided by root 5. Let's make 421. Quadrant 1 equals to x equals to 0.421. Is that just the x coordinate? The value of alpha? Yes, it's correct to two decimal places as well. Let's just quickly check. This is also November 23, 32. A couple of difficult questions here. Yep, correct to two decimal places would be 0.42. Find the exact area of the shaded region. Okay, so for the shaded region, I will need these limits. These are values where the expression is 0. So 0 equals to sine x and cos 2x. Either this equals to 0 or that equals to 0. Now when is sine 0? Sine is 0 at 0, 180, 360 and so on. When is cos 0? Cos 0 is cos is 0 at 90, then 270 and so on. Okay, so x could be pi over 4 or 3 pi over 4. Okay, then it could be other values as well, but I think I've got my two coordinates that I wanted, so I'm going to write pi over 4 to 3 pi over 4. What am I integrating? I am integrating sine x cos 2x dx. Okay, now what I see here is two trigonometric functions that seem to not combine together. Let's try applying an identity. But then this, I could convert this into a sine cube, but do I know the integral of sine cube? That's again a problem, because if I do this, it converts into a sine cube. Okay, and I don't know how to integrate a sine cube. What if I apply the simple identity? Let's see if that helps. It doesn't help on the go. Okay, and this is where the syllabus has become a little more complicated than is what is indicated in the syllabus document. Here what I want you to realize is that this is both a sort of a merger between recognition and substitution, do you recognize that the integral of just cos x is visible outside to you? Okay, so in these cases, as indicated in a previous question where you had sec x and cos 2x in the denominator and sin 2x in the numerator, could I then tell you that the differential of cos x is visible outside? So why don't you just take a substitution? Okay, I'm going to first separate these two so that you can see. Okay, I'm going to take a substitution here and say that u equals to cos x. Now, this wasn't part of the syllabus before, but since this has become important, I am saying that in certain cases you will have to imagine the substitution yourself. Okay, so du over minus sine x is a replacement for dx. So I get what? I get 2 sine x u square du over minus sine x. Only do this when you run out of options. Don't do this on the go. It's going to make things very complicated. So I have minus 2u square being integrated, and that sine x integrates to simply minus cos x. Okay, so I have du and plus cos x outside. Okay, so can I integrate this? I can say that this becomes minus 2 3u plus cos x, and I have the limits. Now I have the limits for x. I can separate the limits for u as well, or I can go back and write cos x cubed over 3 plus cos x. Okay, cos 3 pi over 4 cubed over 3. Let's see if we get the right answer. Root 2 over 6. And this is minus root 2 over 2. Then okay, I'll have to do these one by one. I think I'm messing up the signs. Okay, root 2 over 3, all of them together. So I'm getting minus 2 root 2 over 3, which was obvious because the area was at the bottom of the graph. It was below the x-axis. So I'm going to turn that into a positive and see if my answer is correct. Yes, my answer is correct. And that should be my final answer. Okay, you could have also done integration by parts twice and gotten your answer. That's another sort of idea And I don't want to make that complicated right now because it does get very complicated as we go on. Okay, moving on to the next question. Let's see what I have now. Yeah, I have this vectors question in front of me. It says basically it is given that I think I've kept it for the second part. A lot of you ask questions about perpendicular lines. Where C is a positive constant, it is given that the angle between L and M is this. So angle between two two lines is basically cos theta equals to B1 dot B2 over magnitude of B1 into magnitude of B2. So cos 60, B1 is 112, B2 is minus 24 in C, and the modulus of B1 will be 1 square plus 1 square plus 2 square. 2 square is 4. That gives me 6. And this should be minus 2 square, which is 4, 4 square, which is 16, so 20 plus C squared. Cos 60 is half, and I take a dot product on the other side. I will have to square the sides. So 6 into 20 plus C squared divided by 4 equals to minus 2 plus 2, 4, 2 plus 2C whole squared, and I get 4 plus 8C plus 4C squared, 120 plus 6C squared over 4, 120 plus 6C squared equals to 16 plus 32C plus 16C squared. NC squared, okay, let's put that into quadratic. Yeah, yes, my answer should be correct now. If I put a quadratic, 6, no, sorry, 10, 32, and minus 1, so C equals to 2. Okay, C is a positive constant, so that's just one answer, C equals to 2. Then it says show that the length of the perpendicular from 6 minus 3, 6 to L. L is the first line. So let's just write the equations first. 3 minus 2 and 1. 1, 1, 2. So, okay, then drawing this diagram from 6 minus 3 and 6. So what you simply do is you drop a line and you say that this is the point X, and let's call that point P. Okay, so X will have the general coordinate of the line, which is 3 plus lambda minus 2 plus lambda and 1 plus 2 lambda. Okay, I don't know what point that is, so it's going to be a general point, and then I'm going to say that the directional vector px and the directional vector of the line will have a dot product of 0. Why? Because I want the perpendicular distance. What is px? It's ox minus op. Okay, I can do that directly. Ox is basically the coordinate of x, and p is the coordinate of op is the coordinate of p. So ox minus op gives me 3 plus lambda minus 6 minus 2 plus lambda plus 3 and 1 plus 2 lambda minus 6 dot 112. Okay, this becomes lambda minus 3. So multiplied with 1, lambda minus 3, again multiplied with 1, this gives me lambda plus 1, and multiplied with 2, it gives me 2 lambda minus 5. So lambda minus 3, lambda plus 1 plus 4 lambda minus 10 equals to 0. So that gives me 6 lambda and 12. Lambda should equal 2. So I put that in px. I find the distance, I find the 2 minus 3, 2 plus 1, and 2 times 2 minus 5. So I get minus 1, 3, and minus 1. So px, the magnitude of px will be minus 1 squared plus 3 squared plus minus 1 squared. It gives me root of 11. Okay, that's what I had to prove. Moving on to the next question that I then have. It's the next question only. It's November 2332. Okay, for this question, it's a little complicated. Why? Because these are still on this side of the equation. What I can do is keep them on this side and take this to the other side. In fact, that was better. Keeping keeping dy on top is my priority, so I'm just going to do that. Minus y square minus y equals to 0. Okay, then I have 1 over minus y square minus y dy equals to 1 over x squared dx. Now, if I could factor out the minus here and put it to the denominator and bring this to the numerator because I want to integrate that. The integration here is simple. It's just minus 2 plus 1 divided by minus 1 plus c. What happens on the other side is I see partial fractions now. So I'm going to first take this to the other side and do my partial fractions here. I'm going to say that this can be broken up into a over y plus b over y plus 1. Okay, so taking first y as minus 1, a into 0 plus b into minus 1, so b is 1. And then y as 0 gives me minus 1 equals to 1 plus 0. So a is minus 1. So my partial fractions are basically minus 1 over y plus 1 over y plus 1 dy minus 1 over x plus c minus ln y plus ln y plus 1 minus 1 over x plus c. See what I have? It is given that x equals to 1 when y equals to 1. So c comes out as minus 1 plus c is equals to ln 2. 1 plus ln 2 is c. Express y in terms of x. So ln y plus 1 minus ln y equals to minus 1 over x plus 1 plus ln 2. Ln y plus 1, gathering all the ln's on one side. Ln y plus 1 over 2y. Y plus 1 over 2y equals to e power 1 minus 1 over x. Y plus 1 equals to 2y e power 1 minus 1 over x. Gathering the y's, 2e1 minus 1 over x minus 1 equals to 1. So 1 over 2e1 minus 1 over x minus 1 equals to y. I think that is my final answer. I should verify if that is correct. It's a long, long question. Uh, the answer there is similar. Yeah, it is in fact the correct answer. Okay, there are alternative forms. Then state what happens to the value of y when x tends to infinity, so I have 1 over 2e 1 minus 1 over x minus 1. If x goes to infinity, what I could do is I could plug in a large value for x and find out. But in fact, what I could do is I could say that this 1 over infinity will become 0. So the value of y will approach, y approaches 1 over 2e minus 1. Okay, moving on to the next question now. I think, okay, let's do this. I have the center at minus 3 plus 2i. Okay, equals to 2. So that's the diagram. Find the least value of z for points on this locus. So whenever I ask you for the least value of modulus of z, it's a line stretching from the origin and going through the center of the circle and exactly to the opposite half. Okay, it should be a straight line, not a curved line. Okay, yes, that should be the greatest modulus of z. Z is at the corner. Okay, what I can do is I know that the center is at minus 3 comma 2. So I can first find the modulus of minus 3 and 2. So that gives me 9 plus 4, 13, root of 13, and then I can add the radius to it. So it's 2 plus root of 13. Okay, this was a question from June 23, 32. Okay, relatively simple question. And this is also from June 23, 32. This is a slightly tougher question. Let's try to solve this. Okay, so we don't know an identity for cos half x so far. Okay, but we've done some identities where we have cos 2x as 2 cos square x minus 1. Okay, and then we said cos 4x should be 2 cos square 2x minus 1. And then cos 6x should be 2 cos square 3x minus 1. What if I took this backwards and said that cos x should therefore be 2 cos square half x minus 1? Okay, it's just a multiple, so that's how it's going to work. So this cos x could actually be replaced with 2 cos square half x minus 1. So what that helps me do is it converts an entire equation to cos half x. Okay, and that's generally the objective. So with the 2 outside, so 4 cos square half x minus 2 minus cos half x minus 1. So 4 cos square half x is a quadratic equation in cos half x. Okay, so then I have a quadratic. I'm going to do that on my calculator right now. On the exam, you should make sure that you at least write the quadratic formula on n minus 3 over 4. So cos half x is either 1 or cos half x is minus 3 over 4. Okay, marking the quadrants now, quadrant 1 and quadrant 4. Since the range will also be halved, I'm just going into 4 quadrants, although quadrant 4 is going to get discarded. Similarly, here quadrant 3 is going to get discarded. Cos inverse of 1 is 5 over is 0, and cos inverse of 3 over 4 is 0.723. Okay. So then I get quadrant 1 equals to half x equals to 0, and quadrant 4 equals to half x equals to 2 pi minus 0, and quadrant 2 equals to half x equals to pi minus 0.723, and quadrant 3 equals to half x equals to 2 pi minus point 2 pi, sorry, pi plus 0.723. Okay, so this will exceed 2 pi, this will also exceed 2 pi, so I have just two answers, 0, and I will have to cross multiply that to find out that answer. Pi minus 0.723 into 2. I get 4.84. So 0 and 4.84. Okay, that's the next answer. Let's see the next question that I have. I have the complex number 2 plus y is denoted by a, where y is a real number and y is less than 0. Okay, it's a negative real number. It is given that f of a equals to a cube minus a square minus 2a. So that's an expression. Find a simplified expression for f of a in terms of y. So f of a in terms of y will be 2 plus yi cubed minus 2 plus yi squared minus 2 plus yi. 2 plus yi squared into 2 plus yi minus 4 plus 4y plus y squared I squared. Get 4 minus y squared plus 4y, 2 plus yi, and 4 minus y squared plus 4y minus 4 minus 2yi. I still have to multiply 8 plus 4yi minus 2y squared plus y cube I. This is 4yi. 4yi. Okay. Plus 8yi plus 4y square I square minus 4 plus y square minus 4yi minus 4 minus 2yi. I see something cancelling out. Let's just cancel that out on the go so that my expression becomes simpler. So I have 2 minus 2y squared plus y cube I plus 8yi minus 4y squared plus y squared minus 2yi. So I have minus 2y squared. Okay, no, that should merge with this and that. Minus 6 plus 1 gives me minus 5y squared plus y cubed I plus 6yi. I hope that's the correct answer. This is June 2332. Okay, so let's check in our marking scheme first if you've gotten this correct. So I have plus 6y minus, I have a minus y cubed, I have a plus y cubed, there should be a minus y cubed, and yes, there should be a minus y cubed. Okay, so that's the only problem with this question. The other things are fine, I think. Yeah, okay. Given that the real value of f of a is equals to minus 20. Okay, so what's the real value? What are the real coordinates here? They are just minus 5y squared equals to minus 20. So I'm going to say y squared is 4. Y is therefore either 2 or minus 2. The question tells you that y has to be negative. So y is equals to minus 2. Then a itself was 2 plus yi. So 2 minus 2i. That's in the fourth quadrant or negative 1 quadrant. I'm going to say tan inverse of 2 over 2. That gives me pi over 4. What's in negative quadrant 1? The argument of a will be negative pi over 4. Yeah. Okay. That's the answer to this one. Okay. Okay. The next question that I have is June 2233. Okay. Find in terms of a the set of values of x satisfying the inequality this. So I square both sides. So I get 4 9x squared plus 6ax plus a squared is less than 4x squared plus 12ax plus 9a squared. 36x squared plus 6ax plus a squared is less than 4x squared plus 12ax plus 9a squared. So I get 32x squared minus 6ax. No, not 6ax. This is 24 as well. I messed up the multiplication. Okay, plus 12ax, and I get minus 5a squared is less than 0. Okay, so I need factors for 32 into 5. 32 into 5 is 160. Okay, so 1 into 160, 2 into 80, 3 won't divide, 4 into 40. No, that doesn't work out either. 5 into 32, that doesn't help me get 12. Does it divide by 6? No, it doesn't divide by 6. Does it divide by 8? Yes, 8 into 20 works. Okay, that also gives me 12. So plus 20x minus 80x. Now this is different from your earlier questions where you would, sort of have a simple quadratic inequality or a linear inequality at this point. This is still quadratic, so I'm going to break up the middle terms. I'm going to first factorize these and say that what do I have common? I have common 8x, 4x, 8x minus 8x plus 5a minus a, 8x plus 5a. So I have two factors, 8x plus 5a and 4x minus a. I'm going to first find the roots and then turn this into a quadratic, into an inequality sign. X equals to minus 5a over 8. That's a negative number. And this one is a positive number. Why? Because it says a is a positive constant. So my graph should look something like this. There should be minus 5a over 8 here and a over 4 here. And I'm talking about less than 0. So this is this area. So x is between minus 5a over 8 or a over 4. Okay, let's check if our answers are correct. This was June 2233. Yes, the answers are correct. Let's move on to the next one. This is again from the same paper. This is a complex number question. Okay, this is a complex number. This is represented by this. On an Argand diagram, the point state the type of quadrilateral formed by this. What complex numbers am I talking about? 3 minus I, then the conjugate of that, which is 3 plus I, and u star minus u, which is 3 plus I minus 3 plus I. Okay, that gives me 2i. Okay, so if I'm just going to draw a rough diagram here for you, I'm not going into exactly the grid, although I should do that. So that's O, That's A, that's B, and that's C. So I think the quadrilateral that I'm talking about looks like a parallelogram. Why? Because these two sides are parallel and equal as well. Yep. So yeah, okay, so that's a parallelogram. It's easy 3 marks on the exam. It says express u star over u. So 3 plus I over 3 minus I. I think that's also simple. You multiply by 3 plus I, 3 plus I, and you get 9 minus I squared in the denominator, and you get 9 plus 6I plus I squared. Okay, so that gives me 8 plus 6I in the numerator and 9 minus 1 minus 1 in the denominator. So I get zero point 0.8 plus zero point 0.6I. By considering the argument of u over u star. Okay, so argument of u star over u is simply argument of u star minus argument of u. Okay, argument of u star over u is basically the argument of zero point 0.8 plus zero point 0.6I. That is what I got from here. I will have to check if that is the correct answer. June 2233. This is question number 5. Just to make sure that I don't get it wrong later on. 0.8 plus 0.6. Yep, that is correct. And an argument of u star is basically 3 plus I. Argument of 3 plus I minus argument of 3 minus I. Okay, so this is in the first quadrant. So it's just tan inverse of 0.6 over 0.4. This is also in the first quadrant. So this is also just tan inverse of 1 over 3. This is in the 3 and minus I. This is in the fourth quadrant. So it's minus tan inverse of 1 over 3. Okay, so that makes it 2 tan inverse of 1 over 3 and tan inverse of 3 over 2. 0.8, so 3 over 4. Was that what I was asked to prove? Yes, that is what I was asked to prove. Moving on to another question. Okay, let's see if this question is different. It's just the position of the foot of the perpendicular, so I'm going to ignore that because I've done it once. Let's try doing something more complicated. Yeah, I think a lot of people have had problems with this question, so let's do this. IGK are parallel to AOD and so CM as a midpoint. Find the position vector of M. So I'm asking you to find OM. So I'm going to travel. I'm going to say that OA is 3, so that's 3I. And then AE is the same as OD, which is 2, so plus 2J. And then half of this, and OC is also 2. Okay, so that's 1K. So the position vector of OM is basically 3, 2, and 1. The position vector of P is 1, 1, and 2. Where is P? 1, 1, and 2. Okay, it's not there on the diagram, so 1, 1, and 2. It's somewhere in the middle of nowhere. It's P. Okay, calculate angle PAM. So that's simple. I can do that. I can do cos PAM equals to AP dot AM over magnitude of AP into magnitude of AM. Okay, so AP is OP minus OA. OA is just 300. I could just travel from A to B as well, but let's just do AP. OP minus OA, so 112 minus 300. So that's minus 2, 1, and 2. And AM. AM is 2j plus k. I can see that there. So 2j plus k. That's 4 plus 1 plus 4, and that's 0 plus 4 plus 1. The dot product will give me minus 0, 0 plus 2 over root of 9 into root of 5, and that's spam. So cos inverse then. That's in radians, 0.932 radians. Let's check if that is the correct answer. This was November 2331. November 2331. Find the exact length of the perpendicular. Let's just check. 0.932 radians. Yeah. Okay. Find the exact length of the perpendicular from P. So I have the position vector of P. Do I have the position vector of P? Yes, it's 1, 1, 2 to the line passing through O and M. Okay. So what's the equation of this line? It passes through 0, 0, 0, and it has the directional vector OM. Do I have OM? 3, 2, and 1 is OM. So the directional vector of this line is this. So when I am trying to find this, I'm going to label that X and say that this will have the general coordinate of the line. So that's 0 plus 3 lambda, 0 plus 2 lambda, and lambda. Then what I'm going to say is that Px is going to be perpendicular to the directional vector of the line. How do I calculate Px? It's Ox minus Op. So 3 lambda minus 1, 2 lambda minus 1, and lambda minus 2. The same process that you've seen before. I think this is an easier question to do because it has easier numbers as well. 14 lambda, and I'm getting 7. So lambda is half. Okay, if lambda is half, find the exact length of the perpendicular. So I'm asking you to find the length of Px. Okay, Px is going to be 3 lambda minus 1, so 3 over 2 minus 1, 2 lambda minus 1, so that's 1 minus 1, and half minus 2. Okay, so that's going to give me 0.50 and minus 1.5. So 0.5 squared plus 0 squared plus minus 1.5 squared. See if we get the correct answer. It's root of 5 over 2. Uh, yeah, which is equals to root 10 over 2. That's the answer in the marking scheme. I will be back with more difficult questions in the next video. Please keep watching. Make sure to like and subscribe. Thank you for watching.